Find single voltage source equivalent across the terminals A and B. Hence obtain single current source equivalent also. You have to find both the single voltage source as well as single current source across this. So observe here, it is actually AC problem. We have voltage source, ideal voltage source 20 plus J0, and it is connected across some impedance. So we know that this one is redundant because any element connected across ideal voltage source is redundant. So it is a redundant, you can just remove it from the circuit. So the simplified circuit is 20 angle J0 in series with 4 plus J3. So this is practical AC voltage source, and one more impedance 2 plus J5 is here. So we need to convert into this. So if there is a resistance, how to reduce this means you have to convert this one into current source. Okay, we need to convert this one to current source. Current is given by V by Z. Okay, if it is AC network, we have to call not V by R, it is V by Z. So the value of V is 20 plus 20 0J divided by 4 plus 3J. So you can take the calculator to follow this. To convert this, you have to go to mode complex. The complex is number 2. Okay, in the complex you go to this 20 plus 0J 0I divided by 4 plus 3J 4 plus 3I. I will get um, this answer also you can write, it is equal to 3.2 minus 2.4I. Okay, current value is 3.2 minus 2.4I. 3.2 minus 2.4I. You can also write this answer using polar coordinate shift complex. This option, third option. You'll get 4 at an angle 36 minus 36.86. So that is the value of I. This is the value of I. 4 at an angle. Yes. Now I need to convert once again. I need to convert. Now I have to find out equivalent impedance between these two. This value is 4 at an angle minus 36.86. Now I want to find equivalent impedance between these two. So equivalent impedance of these two is parallel combination of these two. 4.3J in parallel with 2 plus 5J. So using calculator again you can do. You are here already in complex mode. This should be in degree. It should not be in radians. It should be in degree mode. So go here. Now I will multiply 4 plus 3I 4 plus 3I 4 plus 3I into 2 plus 2 plus 5I. Instead of J I am using 5 divided by, in the denominator it is all or plus, no, without open bracket close bracket. You can, if you want, you can write open bracket close bracket, but here this full quantity should be multiplied by this, so that's why you have to use a bracket here. If you miss the bracket, you'll get wrong answer. In the denominator all are addition only, so 4 plus 3I plus 2 plus 5I. You'll get click SD button. 1.66 plus J 2.12 I. If you want to represent using this, shift complex number 3, it is plus ST. You get 2.6925 angle 51.937 ohms. That is the equivalent impedance. Instead of parallel these two, I can write single equivalent impedance. So that is the answer. Okay, the current value is 4.3686 with the parallel impedance of this or this. This is nothing but resistance of 1.66 and inductance reactance of 2.12. Okay, you can write resistance in series with inductance of 2.12. So this is the single equivalent current source with the parallel resistance. If you want to write a single voltage source, convert this current source, convert this current source into series voltage source, multiply just I with R or I with the impedance, you will get this. And same impedance you have to connect here in series. Same 1.66 J2.2 you have to connect in series. Then what is the value of V? We can see. I will show how to multiply also. To multiply, you have to take complex mode. Now angle is 4.4 at an angle, 4 at an angle minus 36 minus 36.869. 869, that is the current value multiplied by impedance. Impedance is 2.6925 at an angle 51.93. You will get 10.39, 10.39 plus 2.75. You have to keep the answer in polar coordinates. Shift complex. Number third option, which is 10.7 at an angle 15. So this is the answer for this problem. Similarly, we can do one more problem on AC network. Reduce the network into single voltage source equivalent. So they are given in millihenry. So we need to convert it into ohms reactance. So they are given ohms, omega they are given. So convert into reactance. XL is equal to omega L. So omega L means omega is given as 300. 300 into 40 10 power minus 3 milli. 40 milli means 10 power minus 3. So it is 12 J. Okay, if it is capacitance, we have to write minus. Okay, capacitance, it is 1 by omega c, 1 by j omega c. So minus it will come. And now it is J12 500. They are in series in parallel with 1100. So using calculator, go to complex mode, perform this, go to complex mode, take fraction box by box. You write here 500 plus J2, you will get this answer. Okay, that is equivalent impedance. So that is nothing but your current source. Okay, current source in parallel with single impedance. Now I have to convert this one to voltage source. So voltage source is current multiplied by equivalent impedance. So it's 50 angle 30 into 344. 344, this is in polar coordinate, it is 344.34. So if you multiply these two, you will get 5165 at an angle 33.3. I'll show you one calculation now. I value is 15 angle 30. 15 angle 30 into impedance 344.34 at an angle 3.37. You'll get this is in rectangular. If you want to see in complex, it is 5165.1 at an angle 33.37 also. So this also sometimes they will ask.